Okay, so in this video we're going to talk about the discriminant. And your discriminant describes the number and type of x-intercepts. Now remember, x-intercepts, make this just a little bit bigger. X-intercepts is the place that your graph touches the x-axis. Those are also called roots, zeros, and solutions. So what we're doing today is describing the number and the type of those x-intercepts, not what they are. Okay? We do that with something called the discriminant formula, which is b squared minus 4ac. And remember that a, b, and c are just numbers, the coefficients, from the quadratic function. For example, over here we give you the function f of x equals ax squared plus bx plus c. So a, b, and c is what we're going to focus on today. Once you get your discriminant, it's going to be a number. And that number is going to fall into one of 4 different categories, which we'll explain below here. First category, if you get your number to be 0, that means your graph's going to touch the x-axis just one time. You're going to have one real rational x-intercept. Rational meaning pretty, like a whole number or terminating decimal or repeating decimal. If your discriminant number is greater than 0 means positive. There's 2 of these. So if you have a positive number, you're going to be in one of these 2 categories. The difference in these 2 categories is if it's positive and a perfect square number, like 1, 4, 9, 16, 25 on your list of perfect squares. If it's one of those numbers, it's going to be in this category, which means you have 2 real rational x-intercepts. Again, rational means pretty. So you can have 2 real pretty answers, like maybe -1 and +3. Your graph's going to touch the x-axis 2 times at 2 very nice locations. If your answer is positive, but it's not one of your perfect square numbers, then you're going to have 2 real, but it's going to be irrational x-intercepts. Irrational is kind of like ugly numbers, not going to be very pretty, maybe decimals or ugly decimals, not terminating or not repeating. And your answer is going to be something very ugly form like these fractions over here with radicals still in them. Okay? If you do your discriminant formula and you get a negative number, less than 0, so a negative number, you don't have any real x-intercepts because you're going to have 2 imaginary solutions. So your graph will not touch the x-axis at all, as you can see here. Okay? You have no real roots, no real zeros or solutions, because you're going to have 2 imaginary answers, which means they're going to have I's in them. The letter I we talked about with the bell ringers. Okay? So we're going to do a couple of these for examples, and you're going to notice that your notes I have here on the screen are also screenshot, and they're going to stay on the side over here the entire time. So we do a couple of different examples. We'll start off with 9x squared minus 12x plus 2 equals -2. Now, to do this problem, you have to make sure that you have A, B, and C. And right now, we have an A, a B, and a C, but we also have this right side number here, which we have to deal with. So we need to make sure that we set this equal to 0. So actually, you have to solve this problem first by adding 2 to both sides, because you want to get your equation, your function, equal to 0. So by adding 2, you're going to cancel these 2 out, and you're going to end up getting 9x squared minus 12x plus 4 equals 0. Now when you get here, you can use your formula. Remember, your formula is b squared minus 4ac. And when you use this formula, you have to use parentheses appropriately. So b squared, b's in parentheses, the square is outside, minus 4 times a times c. And we can label our problems so we don't get confused here by our a and our b and our c. So if you fill in, you use substitution, b is actually the number -12. So b is going to be -12. Your a is 9, and your c is now 4. We're going to do some simple computation. Now, you can type this in the calculator exactly the way you see it right here, using your parentheses appropriately, and you're going to get the same answer that I'm going to get by working it out by hand. Okay? So if I do this, when I square -12, I should get 144. Minus 4 times 9 times 4 is 144. So when I do this, I get 0. So if you type this in the calculator before I did this, you should have gotten 0. That means that your discriminant is equal to 0. Now, if you recall, using your notes here and on the side of the screen, if a discriminant equals 0, it puts you in this first category, which means you have one real rational x-intercept. So you're going to touch the graph, the x-axis, one time at a really nice location. So your answer is 0, and that means one real rational x-intercept. And you're going to write that down. That's your description right here. That's what we're looking for. Okay, let's do another one. Let's do x squared plus 5x minus 3 is negative 7. Let's do this one. Now remember that right side has to be 0, so you're going to start off by doing the inverse. You're going to add 7 to both sides. Okay, when you add 7 to both sides, you get x squared plus 5x plus 4 equals 0, which is exactly what you want. You want this equal to 0 right here. Now let's use our formula, b squared minus 4ac. Put your parentheses in there, don't want to lose those. Label, that way you know you're doing this right. A, B, C. Now if there's not something in front of your x squared, remember there's always a coefficient there. That coefficient happens to be a 1. So my B is 5. My A is that 1 we just talked about. And my C is 4. Now again, you can type this in the calculator just the way you see it right here, and you're going to get the same answer I'm going to get when I work this out by hand. 5 squared is 25. 4 times 1 times 4 is 16. 25 minus 16 is 9. So my discriminant equals 9. So if you look again at your notes to the side, try to figure this one out real quick on your own, what category it's going to fall under. So if we look at it, we know it's a positive number because 9 is positive, so it's going to be in one of these two categories right here. Remember, the difference is this one is a perfect square number and this one is not. So what would we consider 9? Is 9 on your list of perfect squares? Yes, 9 is. So it's going to be in the second category. So you're going to have two real rational x-intercepts. So you're going to touch the graph 2 times at 2 very pretty nice locations. So you would write that down. 2 real rational x-intercepts. And that's your description right there. Okay, let's do another one. Let's do 6x squared plus 5x plus 7 equals 0. Now this one's even nicer because they already said it equals 0 for you. So there's no pre-work in this one. It's already worked out. All you got to do is use your formula. So b squared minus 4ac. Put your parentheses in there. Don't ever lose these. Don't ever forget these. Don't forget to label your a, your b, and your c. And just plug in and see what you get. So your b is 5. Your a is 6. Your c is 7. And do some math here. Now again, type it in. If you're concerned about missing some computation here, you should get 25 minus 4 times 6 times 7 is going to be 168. So 25 minus 168 is going to be a negative 143. So your discriminant is a negative number. A negative number. So if you look again at your notes, your 4 categories, it's not 0, it's not positive, it's negative, so it has to be my last category here, which means I have no real solutions. Because I have 2 imaginary solutions. I don't touch the x-axis at all. If I graph this function, I have 2 imaginary solutions. So you would write that down. No real, but 2 imaginary solutions. Okay, let's do one more. Your last one here. It's going to be 5x squared minus 8x equals 3. And remember, you have to have this equal to 0, so it can't equal that 3, so I'm going to subtract 3 from both sides. You're going to get 5x squared. Do not make this common mistake. Negative 8x and negative 3 are not like terms. You cannot combine them. So you have to write them both down, and that becomes your b and your c value. So if you'll label A, B, C. Do your formula. So b squared minus 4ac, put your parentheses in there, and start plugging in. So your b in this case, -8, your a is 5, and your c is -3. Do some computation here. Type it in just the way you see it if you want to. You can do some by hand. -8 squared is going to be 64. 2 negatives is going to make this a positive. So 64 plus 60 is going to give me 124 for my discriminant. 124. So if I categorize it in one of these four, it's not 0, it's not negative, it has to be one of my two positive categories. 124 is positive, but is it a perfect square or not a perfect square? It's not a perfect square. So I'm going to be in this category which says I have two real irrational x-intercepts. So two very pretty answers. So two not pretty answers. It's going to be two decimals or two ugly looking fraction problems with radicals in them. So you would say over here your description would be two real irrational x-intercepts. Okay, so that concludes our notes for this section. You got some example problems to kind of go by. In class, you're going to work on some of these on your own. So remember, a discriminant does not find the roots. A discriminant categorizes, classifies the roots, the number and type. 1, 2, or none, rational, irrational, or imaginary. Okay, got to know the difference. All right, thank you.